Testing. Okay, sweet. Okay, guys, sorry about that. I don't know how much of that you guys caught, but thank you all to who showed up. Special thanks to you guys here at Adobe who have made this possible and for taking time out of your busy days to come and give this tech talk. So with that, I will turn this over to you, Arvin.
Hey, thanks a lot. My name is Arlen Shaker. I am manager at Adobe that we started this new group recently, working on a building a real-time 3D code base, I would say, more than like a rendering engine that's shared across products within Adobe, and we'll start replacing um, other 3D engines that are used in common Adobe products, and including Substance products that are coming out now. But I just wanted to like set up this. It was actually one of our TA guys that like decided that we should like set this meeting up and like try to do a Q&A, and I think it was a great idea, and I want to actually get into like the actual grits of like the tech that we do, and get kind of the broader answer, be able broader questions, and like be able to see what else is going out in the community, and kind of a two-way street here. So I just want to introduce everybody else from Adobe that's on this call. Um, so I think we have uh, Phoenix, Eduardo, and is Brent on? I'm not sure, but Phoenix, if you wanna, I know you were um, on the mic. If you wanna kind of introduce yourself a little bit.
Yeah, totally. Hi, how's it going? It's really great to be here. Thanks for having us. So I've been blending my passions of computer graphics and systems engineering, maths, and loving to help artists and gamers for quite some time, over 10 years. Um, I'm what I've really enjoyed about being part of Aero and the real-time rendering team is that I'm able to coalesce like all these different passions of CG, maths, artists, gamers, and like really low-level system stuff all together. It's fantastic. I've worked on a number of proprietary as well as commercial rendering systems, both offline and real time. I've been working alongside tech and artist teams developing solutions and core systems. It's um, uh, it's a really great experience translating all of that into the product that we've got with Aero and with the real time system that we're developing across all the different products. Uh, Lucasfilm Animation, double negative visual effects, and 2K games are a few of the studios I've worked at. And I've worked across a ton of different platforms from PlayStation, Xbox, Switch, Mac, Windows, Linux, mobile. The list really goes on. I have this little mantra that I have in myself, which is I believe in making the world a better place, and I love doing it with every pixel that I push and every line of code that I write. And I think personally, Adobe has really made me able to do that in a very new and exciting way, working in the augmented space. Um, One thing that's been really interesting about coming into this chat before I get Eduardo to introduce himself, it'd be great to kind of see where everyone is from in the chat. If you were to like, say where your location is, it's really great to connect up and just see all the faces and voices that are involved here. So that would be great to see. And Eduardo.
Thank you very much, Phoenix. Can everybody hear me okay?
Yep, you're coming through loud and clear.
All right, perfect. All right, nice to meet you guys. Well, my name is Eduardo Chavez, and Riggy as well. I'm an engineer in the rendering team, the engine team. be doing mostly uh, systems, rendering architecture, but focusing on a little bit on techniques as well. My background is I come from gaming pretty much. I worked on some smaller independent studios in Brazil, where I'm from. Currently, I'm based in San Francisco. But later, I got my computer science focus in games, a degree in computer science focus in games, and in Redmond, Washington, where I also worked at Nintendo, doing a little bit mostly gameplay, but some engine work as well. But I always had a passion for engine development. I was doing that college, professionally, and I guess my switch to engine development was when I joined Unity as part of the VR and AR rendering team. Worked there for a while, and then I had the pleasure to join the team at Adobe when we were just starting to make this amazing tech. And glad to be here. So I'm also let's contribute to Phoenix request. Like I said, I'm from Brazil, but currently based in San Francisco, California.
Cool. Yeah, and that's Arvin again. I've been I came from a simulation background actually. Started at Evans and Sutherland about 20 years ago. Kind of been doing simulation and rendering engine development for a long time since then, mostly for image generators for simulation and a little bit on operational military um, engines. So it's like we have a pretty big spectrum of different types of tech that we guys have done, and it's really kind of interesting to see what is different about what Adobe does. We're trying to like create products for creatives, and so it's pretty different than like being able to do like title based games or do movie visual effects. There's a lot of kind of unique challenges, and I think we'll like start going through some of those, but I kind of want to get straight to question and answers if that makes sense, and kind of just go in order, if that's cool with you guys. I guess the first question that I see in here is tech behind Adobe Fresco, which is actually a lot of fun. We I worked on that for a little bit when I first got here. So I don't know if you guys are like if all of you are familiar with Adobe Fresco. It's a interesting platform to allow people to do digital paintings in a lot of ways. So it's very focused on being able to do paint or ink on paper and simulate what's going on behind there. So I can tell you like really quickly how that tech works. Basically, all done with GPU computing in a graphics pipeline. So we start with a tile-based compute shaders, and what we want to do is we want to calculate the amount of paint. For example, I use paint in the generic way because you can do a lot of like interesting digital paints based on it. And what we want to do is we want to calculate the advection and absorption. Advection meaning how fluids like or actually move on a surface, and absorption is obviously like what gets absorbed into the paper in order to get an intensity that's spaced out there. So all in compute shaders, tile based, be able to calculate a velocity for the ink that's going out for every pixel, be able to do that by iterating on a Jacobian, do that like in several passes. So it might be like 10 passes that we do um, to be able to iterate that, and then be able to calculate um, a velocity vector, be able to calculate the absorption and the um, um, uh, on paper, and then be able to do the lighting on top of that. Be able to do a BRF, depending on what kind of material you have, in order to actually like show that on the screen. And so it's pretty interesting tech, and this is why it doesn't like quite run um, on lower end devices. But just to kind of give you an idea of the types of kind of broad spectrum um, ideas behind rendering, this might be one where our group gets involved a little bit in order to make sure that we have the same kind of material basis across our products as we go forward. We don't know whether that's going to happen or not, but it's one of those interesting things that's happening at Adobe. But I'm going to move it on to other people. If anybody wants to take over another question.
Yeah, I will say, hey, this is really cool to see people from Russia, Virginia, France, Scotland, Philly. Hi, everyone. Absoli. Hey, Geometry from Israel. Geometry is greater than every other shader from Israel. Hello. This is very cool just to see the reach of everyone here. This is fantastic. I'd like to tackle Blue Coder's question, which is what are the common programming languages used behind Adobe products? And does Adobe use OpenGL, Vulkan, and the ellipsis there, every other tech under the sun for the rendering? Well, Adobe is predominantly a C++ and C company of the languages that are being used. That's for the main products. It's actually very interesting to see that some products use JavaScript front ends as well as C++. One of the things that we see is that there's depending upon where you are in the application stack for the product, you might be using slightly different languages. We use in Aero and in the rendering engine, we use predominantly C++. And we do have some bindings to JavaScript as well. That's in terms of rendering engines. Adobe has for the last few years OpenGL has been moving to more modern graphics pipelines. So there are some products that we've got out there, and I can't recall all of them, but they're working on Vulkan. I think that was some of our Android-based devices. And for Aero and our rendering engine, we actually do support a number of different contemporary rendering backends. So we do support DX11 and DX12 for Windows, but we are supporting predominantly DX11 with a move to DX12 on the cards. We have been testing Vulkan as well, although that hasn't been pushed into production or anything like that, but we are working on it. And Metal as well, because we're predominantly on Mac at the moment. So the general push has been to move away to move towards contemporary modern APIs. And that is one of the greatest pushes with our rendering team, which is what we're enabling Adobe to do.
And Apple dropping OpenGL support is a big factor in migrating to different rendering pipelines. So I think that's one thing that's like pushing kind of our group to be able to like move into different places, is to kind of take over older OpenGL based pipelines. If that makes sense.
Yeah, that's a very good point. That's the main push for moving away from OpenGL for the Mac system, which then kind of introduces the question of, okay, so if we're moving away from OpenGL, what do we have? And then what kind of solutions do we propose to be able to cross that bridge? Yeah.
I think this next question, which is about best practices, a little bit broader scale, but I think doing this for a while, it's really hard to like do best practices to writing a scalable and maintainable code. The only best thing that I can see is having a great team around you. This is really kind of the most important thing. I'm not a big fan of um, overly doing test driven development or things like that. If you have like good engineers that are doing high quality code, letting them to do that properly, being able to work together in a group, being able to have people um, take good criticism, be able to push PRs and do reasonable reviews is usually the best thing. I'm also come from a software architecture background, so I think that spending a little bit of time just like naming things properly and being okay with throwing away code and redoing it when you need to is really important. But I'll open that up to everybody else to see like kind of what their thoughts are on best practices.
Yeah, I fully agree, and I think one of the challenges is balancing processes and development time, because we have our own internal processes and which help us maintain the quote quality. But when it comes to, I think what Arvin mentioned about having a good team, also entrusting uh, the quality of engineers, is it's very important, because at some point too many processes, they can slow down development quite a bit, can impact development quite a bit. So I think finding that balance is, I think it's on a per team and per project need basis. But it's we tend to uh, lean towards the, I guess, what is the fastest that we can move while uh, with some checks, and but also leaning to the quality of the people that we work with.
Yeah, exactly. And then yeah, moving on to the next question. As far as making the same application work on many different platforms with vastly different capabilities and software stacks, it's actually even harder than that. We're actually trying to, whether or not we succeed is still an open question, but we're trying to do a common code base for many different applications that work on many different platforms and do very different things. So I'll talk a little bit about that. So the way that we're focusing on building our internal real-time interactive engine rendering engine is not having one rendering engine that like fits everything, but being able to build a solid code base where we have every application can define their own render pipelines, but be able to use common tools in it, common channel sets, be able to, when somebody adds specific BDRFs or materials or adds uh, interesting techniques for like soft shadows, that the rest of the applications can come together, and on top of that be able to like maintain the same type of visual fidelity across products. Obviously that's going to depend on platform requirements. When we're talking about Aero running on an iPhone 7 is going to be completely different than running Dimension with a full um, path tracing GI on a workstation or within the cloud. But having this common type of code base, having a set of developers where we can share these features around each other is, I think, going to be very helpful for us to start doing those things. Um, and so that's really issue of testing resources and organizations being able to work well together. So having applications to be able to test their applications properly as they get new code stacks, as they get new pulls from other code repositories, and also being able to do that internally to do regression testing within our engine stack. This is something that we are still in the process of getting right and seeing how that works. So I think it'd be interesting to see what happens over the next year or so in order to do that. Um, as anybody else want to chime in on that one?
Just a quick comment. Another, also besides having an architecture that allows for separate pipelines, I think having different LODs as a first class citizen as well. So being able to scale your assets and the quality that you need, like you mentioned, from an iPhone 7 to all the way to a workstation, that's something that I think it's also critical for whatever rendering engine or technique we're using to scale properly.
I think that's a great comment on the challenge that's there. It's really hard to even figure out how much resources you're using at any given time on different platforms. Like how much memory do I still have available when there are a lot of apps that are open on my phone? How much GPU time do I have? I mean GPU memory do I have? It's not as easy as it should be on that. I don't know if Phoenix wants to chime in on kind of doing those metrics also, or Eduardo.
Yeah, capturing some of those types of metrics is pretty system specific, and one of the ways that we provide different applications to be able to tap into the different ways that we approach it on different systems is to provide very nice, neat APIs to be able to query all of that stuff. One of the benefits of being able to work across all the different, well, we don't know what every single device capability is out there, but what we can do is take a very good sample from some different devices that we have available, and we do some testing, so we can kind of provide some basic default configurations that then we can build over time through metrics on the actual device and be able to adjust our understanding of usage. But yeah, it's if someone's the case that Arvin pointed out, when you have 30 apps that are open on one device, and you're querying the kernel for how much memory exists, it's not as clear cut as what we would like.
And then that kind of goes into the next question where it's talking about the um, hardware features that we'd want more. Like that would definitely one in terms of hardware features. I would love to have GPU driven pipelines on every device, but we haven't. We're nowhere near that. Like to be able to do that. Software features, I would just love to have C++17 just standard file system work on everything. That would be fantastic if we could do that. But well, yeah, we're still not even near there.
Yeah, and the reason for some of the code things is because of the compilers that we're using, and vendor implementations aren't consistent with what they support across the different devices, and so yeah, that's a bit of a challenge, as we'll get to discuss in a couple of more questions time. But I think from the hardware point of things, there's to pick one hardware feature is just too difficult. There are so many different components across the rendering pipeline on the host side and on the device side, that you can pick and choose on each one. However, if I'm casting a long bow all the way um, to the future, what I would really like all the device manufacturers to really get in there is to be able to support, have much greater support around ray tracing silicon. To be honest, and this currently what's available is really good, and I just want them to up it a notch so that we can really produce some great visuals.
Yeah, plus something that's cross vendors rather than having to be associated with RTX. NVIDIA, I love NVIDIA. Like, don't get me wrong, but um, being able to do things that are a little bit cross vendor would be a lot easier. Eduardo, do you want to talk about testing infrastructure and kind of like where we're going? We don't have it set up as nearly as what we're trying to do, but
Yeah, touching just a little bit on that. So I think definitely having a shared infrastructure like we're doing right now, it's something that makes it a lot easier to ensure consistency in our in across products as well. Um, but in terms of infrastructure, we our idea is to pretty much have just centralized code base that uh, we share across teams, but each team is allowed to also have their own custom tests if they want, uh, and build on top of that. And but features that we believe are should be shared across teams, then it gets into a main, uh, let's say, test that if you want to ensure a feature goes into that code base, then it needs to be tested and checked against all products. But to in and this is mostly for regressions. But if you want to uh, uh, test quality, we I think we're using a standard um, technique to just generate. We have template images. We generate renders against that, and then we choose what's going to be our gold standard, and then we automatically test against those.
we actually are almost halfway through this, so let's we'll kind of go a little bit faster through some of these. We skip ahead a little bit. There's an interesting question about AR and the key challenges mapping the real world environment and lighting reflections on simulated objects. So I would actually love to elaborate on that a little bit. Um, for our AR stuff, we've been relying on the actual device vendors and what they've been working on to be able to do things. But we have a great research organization at Adobe, and they've been doing a lot of. We have a machine learning platform called Sensei, and obviously have access to a lot of different types of assets that we can build in house to train great models. So we have a couple different projects that are already public. We've done sneaks on them at Max. Um, One of them is called True Light, which is a great Adobe project that came from being able to take panoramic 3D HDR images and being able to train models to be able to take a piece of them and figure out where lighting is coming from at any point in time and actually output spherical harmonic probe for that at any given position within that image. And then there's a separate model that we also use that'll do it for actually detecting lighting for an entire image. So that, along with ARKit and what AR Core brings, we're testing out all of these different models, beginning to try to get them into production. One of the great things about engineering, in my opinion, is it's really there's a lot of work to be able to take something that comes from theory or something that comes from a research project. If you guys have been doing that in grad school or something like that, or afterwards, and then being able to like make it into production and be able to like get all the details done to be able to get it working. So that I think is like a pretty exciting path that we're going down. Um, if either of you guys want to like say anything else about those?
Yeah, just it's interesting too. There's a lot of stuff going on Adobe Research, a lot of exciting projects, but this there is the challenge of also some techniques they will take you 90% there, and what do we do with the last 5%? So that whole tech transfer part of our work is super interesting, challenge on that regard.
See. And so I've noticed some comments about ray tracing in here. Um, from Adobe Research, Dimension built their product based on a offline path tracer, also using RTX to do accelerated rendering on it. Our plan for this year with our group is really interesting because it is to kind of converge from the real time side and the offline path tracing side to be able to get kind of convergence in visual fidelity with the ultimate goal of having real time path tracing be a thing that most people can start to use at some point in time as hardware gets better, as techniques get better, as we can start using. So some obviously some clients, some applications, when we're talking about things like After Effects or doing things for movies, there's going to be more of a push to things done quicker, but can be done offline. But there's a lot of use cases where our customers just want to be able to see what they're doing and got to have that what you see what you get and use that quality right away. And I think that technology is converging to that point where we're going to be able to do that within the next several years. Either of you guys want to like comment on path tracing or RTX?
Yeah, I'm seeing that for the short term, we are going to be looking extensively. Well, we are looking extensively at hybrid systems and where to insert it within our kind of real-time rendering framework that we've got. As Arvin pointed out, it's more of a code base, and the way that we kind of approach developing the render pipelines, it enables a lot of the different teams like Dimension to be able to, and Aero to be able to customize their essentially their pipeline. So the challenge for us is to try and develop the nice type of uh, framework for them to be able to tap into in order to be able to leverage and perform techniques that they need in order to get the results that they're after using ray tracing techniques and path tracing techniques that are available. Now, right now, the APIs are very different that we're looking at, and it's really nice to see that we can approach it in a certain way. So the quicker that the industry can kind of formulate a standard, it makes it a little bit easier for us. But definitely from an architectural standpoint, the way that we really envision that there'll be many devices that it's just going to be available for everyone to use, and just about tapping into that. So for our products, we really want every product to be able to leverage that, and we want to make it easy for all the product teams to be able to define and access it. So it's very interesting from our engine architecture perspective, how we're going to be creating this hybrid system, but also very interesting to see the developments that are happening on the hardware level and the API level. So lots of different components, which kind of make for a very, very exciting future.
And following up on that, there's questions about API and top level abstractions, and I think we can talk about that a little bit. It's not like super like proprietary information or anything like that. We've been using internally BGFX for Aero at that kind of like top level abstraction, be able to use Spear to do cross compiling of GPU code. It doesn't move fast enough for us. Things like being able to have um, uniform buffers and things like that. Just like it's not quite there, and proper Vulkan support is also like a little bit lacking sometimes. So, given our acquisition of Substance, we have like a great team out in France, and they're helping us build a internal abstraction layer that's going to be more modern, something that we can kind of keep up with and be able to do that. So I think top level abstractions are important um, to be able to support a lot of these devices, especially GPU cross compiler. But these are kind of all merging pretty consistently. It's pretty easy to port code between Metal and DX11 and OpenGL and Vulkan nowadays, because the feature sets are kind of converging a little bit. But it's
Yeah,
kind
that
of
Yeah, and that's lovely because well, there's a question. Where was it? From Trel. From I hope I'm pronouncing this correct. Traldera. I'm not sure how to pronounce this. I hope I'm getting it right. And it's talking about the question is if you were hiring for an entry level rendering position, what skills, knowledge would you look for in a candidate? Examples would be lovely. And which languages, APIs do you consider most relevant? That's a that last point is these modern rendering APIs have started to understand from the years that we've learned what's kind of needed, and so they're kind of converging on very similar concepts. When AMD kind of kicked that all off, it's really nice to kind of see how that's evolved through Microsoft and through Apple and with Kronos, with Vulkan. It's really nice to see this kind of convergence. So, the challenge, while there's a lot of tools out there that make our final pixels very consistent across different devices, it's still quite a challenge to be able to have a very consistent and neat API to be able to talk to. And so, yeah, we've got this great team in France that from Substance that are really helping us out on that. And we're working together, which is really great. And so, in terms of where someone might be wanting to look at from a skills perspective, uh, and no disrespect to OpenGL, but I would just let it go. I would just leave it be and focus on one of the modern graphics APIs and learn that one well. You know, our team is very fortunate that we have got an expertise and have dived into all the different contemporary APIs, and the concepts are the same. They just have slightly different labels. So and there are some features missing between them, but there is some convergence, and that's where I think we're going towards. And creating that abstraction is what's needed, but sometimes you need to get in underneath the hood, and that's why while BGFX is a superbly great piece of software and a great tool, you as we kind of develop, we don't get the capacity to be able to do certain things, and we need to branch out into these uh, additional lighter weight abstractions.
Yeah, this is great. We're going to continue going on this for a little bit now. I just, given what Phoenix just said, I just want to put a plug in there. and remind you guys at the end. We are also hiring, so if you are interested in working on these types of things and getting knowledge about what's going on, or if you have like great outside skills that we don't have that be really cool, please let us know and send us your thing. On that note, Eduardo, do you want to talk a little bit about there was the question about given a wide range of hardware and features targeted, how do you handle the shader permutation explosion? Do you want to talk a little bit about how we deal with procedurally developed shader code and Uber shaders versus moving to different things?
Yep. Yeah. I was actually about to segue on that. After Phoenix talk about different platforms, it's an excellent question. So the pretty much the way we're handling permutation explosion is by not doing permutation. So we are trying to avoid we're avoiding having overshader with the and compiling with different flags for different uh, platforms or even different material types. Our strategy is pretty much uh, so very quickly touching on how we handle uh, render pipeline, render states. What we do is pretty much when a new render state comes to the engine evaluates to see if all the resources are ready, and that includes our shaders as well. What we do is we check the needs of the materials, the render passes, the platform we're in, and then we have a hash of all those states that can contribute to a new shader, and then we check if we have that shader already. If not, then we generate it procedure generated uh, at the time of execution. So we assemble the shader code based on bits of shaders that we have. We call them channel sets. Everything is procedure generated currently based on the pixel shader, and it also generates our vertex shader as well. After that, that's assembled, it's compiled, everything asynchronously, and then we add it to our shader cache as a new shader that's available. So, for example, if you the first time you run Aero, for example, on your device, um, it will generate all the shaders for you there. If you run it again the same with the same materials, the subsequent runs will you already have them all cached. So, and this is we find this is a little bit better than having to deal with all that explosion of permutations.
Well, that's great. I just got a message from one of our guys. The actual he's the software architect that we have that kind of built most of this code that we're running on. I haven't verified this, but it says that Unreal Engine 4 is just dropping GL support. Um, so again, to Phoenix's point, if you guys are interested in developing things and working with stuff, like try to avoid GL and start working towards one of the other more modern, closer to hardware frameworks. It's kind of more useful. Rodrigo asked the question: Are missing features between different APIs an issue? It is, but you gotta kind of, if you're gonna build a broader pipeline, you gotta be able to either take the common code base that's used for all the devices that you want to do, and then be able to take specific features and be able to say that I need to spend time to accelerate it on certain hardware, and therefore we're going to spend time to do it just for this. But that is a business decision that you have to make, and a lot of software engineering comes down to business decisions when we're trying to prioritize tasks and be able to figure out what to invest in versus not. Um, and by just got a question about what the contemporary frameworks, when I'm talking about that, I think we're talking about Metal, Vulkan, and DX 12 and DX 1112 um, when we're talking about those, as opposed to OpenGL 4. Sound about right to you guys?
Yeah, that's exactly right. That you've hit the nail on the head. So Thanks for Will Stall. Thanks for asking that question. That's really good. Yeah, spot on. That's where the focus should be. And what might be what is the great takeaway from that is to not, you could do, once you learn one, all the others are not as hard to learn. Right? So it just takes time. So like, some people, I've talked to some people before, and they're jumping between each one and correlating all the different concepts, and everyone uses terminology that's slightly different. And so, if you learn the concept, it's going to be consistent across all of these different APIs. So focus on one, get it down, and then you'll see that when you look at the others, everything's going to become much clearer. Which isn't to say, if you want to jump between them, I'm saying you shouldn't. No, that's not the case at all. It's just, you know, uh, in the general case, if you focus in on the one, then popping back up the stack and looking at all the others, everything will be so much clearer.
I agree. There was a quick question about spherical harmonics, just for people that don't know what that is. It's just an approximation. So think about, your Taylor series approximation for things. It's doing that basically, except instead of doing it based on a linear, spherical harmonics is based on being able to do that for basically a Fourier transform. Um, so what we're doing is have a very, very small set of coefficients to be able to create a IBL without actually having all of the pixels involved. So what we'd use it for is for lighting estimation, being able to spit out a few different coefficients that's going to tell us, primarily what the lighting direction is, but at higher frequency. So I might have several different, um, intense areas of light, and just be able to do that by putting it in terms of just like maybe 100 numbers instead of a huge IBL pixel image. So that's what it's very commonly used to be able to do lighting probes in scenes efficiently. Um, but mostly just for lighting. It's not really used for like reflections or mapping shading. It can be, but it's not like a full on HDR IBL. Um, there was a question about BVH generation and traversal as a black box. So that's a great question too. Um, in research, so from dimension side, research built this project called Lantern from scratch, and it was originally CPU based. And I'm not an expert by any means on what they've been doing on that side for the path tracing. But they were able to optimize it really well to run as quickly as possible. And then when they did RTX acceleration, I know they worked really closely with NVIDIA to be able to kind of port their code over in the right way. I know that they had concerns about a lot of the BVH and traversal as a black box. So I'm not sure exactly how they implemented it. As we move forward, we're going to have to see kind of the different things that we can do. And also, we do not want to be tied to just NVIDIA for most of our code. There's nothing wrong with having a path that is vendor specific. But like I said, we're a big company. We have a lot of different customers using a lot of different hardware. We want to invest in things that have kind of um, a broader sense in there. So we're gonna have to figure out how to go about that. Um, I do not personally enjoy the fact that it's a turnkey solution for that. I think it's great to like learn to be able to do like certain projects on your own. I think it's terrible for a um, for a company like Adobe that's building commercial off-the-shelf products to have to be limited to. Um,
Yep. Yep.
Yeah.
I was the one asking the question. Yeah. So just to follow up on your reply, actually, I'm asking this question because in a couple of weeks, I am lucky enough to start a master's thesis on acceleration structures, and this is kind of an issue I have where I would like to benchmark whatever I come up with and whatever the state of the art for software-based ray tracing on a GPU can be versus the NVIDIA stuff, but I can't really do that and have proper results because I don't really know what they do. I don't really know how
Yes,
they handle
and
it.
so they have some very interesting things that are happening, and I'm not sure if I would one recommendation I would have is to have a search around for Timo Virtanen. Um,
Uh,
I
how do you spell it? Can you please?
um,
Type it in.
I believe I think it's either double I or double T. I believe this is. I'm trying to read my handwriting from a while ago. But Timo is an engineer at NVIDIA, and he's actually looking into this particular thing that you are speaking about. And it's very interesting because we're looking in regards to this limiting factor, it is very limiting. And I feel that it will be for quite some time. I believe the manufacturers are still trying to work out uh, the right mix between their hardware-based solutions, their driver-level interfaces, and then the application interfaces. And so they've been working on this for quite a number of years. And just in the last couple, where it's really hit us and we start to play with it, it is quite limiting because there are certain nuances to the top level and bottom level acceleration structures that we must feed based upon the vendor. It's their choice. It's what they've decided to kind of do. And so when you have to work within a particular construct and you don't have that freedom, then it is always limiting. And so, you know, we try to push those limits and see where we are. And our research team has done some great work in being able to talk with NVIDIA to try and get the best um, out of their hardware. But at the same time, it's I think it is also helping to inform, in this case, NVIDIA and other vendors as to how they should kind of structure and think about the requirements that people have for these BVHs. So yes, it's I think you're right in a very good position with your masters that you're about to begin, because this is a very hot topic. And if you, I believe Timo's got some fabulous papers that are out there. So yeah, check him out. And I believe he has a couple of talks out as well, which are really great to kind of understand from the problem spaces that NVIDIA are at least looking at from the driver level, you know, and that's before it gets to I guess their forward-facing application interfaces that we end up talking to, right, through whatever API that is, whether that's a DX API or through a Vulkan API. So yeah, that's a really great question. And no, you know, instead, do you enjoy the fact that it's a turnkey solution? It's the solution that we have right now, so we work with it, right?
Yeah.
And as things improve, well, like a great thing is that we can update the acceleration structures in between frames. So that's a great thing. We don't have to rebuild the whole thing. You know, that's a huge win.
But it's still like a black box API at the moment, at least for the NVIDIA stuff, as far as I know. I've looked at
Yeah.
the specifications.
And hopefully one day
But
what we have is
you can
a
also go to RTX
programmable
Metal.
interface.
Oh, sorry.
Yeah, and hopefully one day the the ray tracing side of things on the hardware becomes programmable interfaces like shaders are now, to that kind of level of flexibility.
I mean, they have programmable hit shaders and stuff, but the actual structure of the acceleration structures is not really is fixed function. It's not
Yeah, it's
configured.
definitely black box.
Yeah, that's right. Yeah.
Yeah. So
So just
sorry.
wanted to know, like we only have a few minutes left um on this. We can keep going a little bit over, but I just wanted to do a couple things. First, to Phoenix's point, especially for people that are in research or even just in industry, there's nothing like reaching out to people and like being able to do that. Like you're certain, you read some papers, you do something like everybody's super interested in like connecting with people or being able to talk to people. And I think that's one of the things that's kind of hard for a lot of people to start doing or to start understanding that. But nobody's like so important that you can't like reach out to them, be able to like send them an email, be able to find them on social media. And this is great. That definitely works out really well. So I definitely encourage everybody to just like Phoenix was saying, like this is the guy working on it in NVIDIA. Let's just talk to him and be able to do that. It really can accelerate your career either in academia or in industry by doing that. I think a lot of people that have had success can confirm that that's kind of one of the reasons why. Um, I do want to, before we go, reiterate that we are also hiring. If anybody's interested, please reach out and let us know. We're looking to expand our team to be able to do all this crazy stuff that we're talking about doing. But we maybe have time for like one or two more questions if anybody has anything that they think that we haven't covered that they really want to like put up there. Here's a good one. Yeah. Um.
Well, I've got this great one. Someone asked about Sean Parent.
Yeah.
It was Thomas. Thomas Latham. I hope I'm pronouncing your name correctly. Sean is a fantastic person, and his skill and expertise in C++ is absolutely fantastic. And most recently, I'm going to post a couple of links to help answer that. There's been some interesting discussions happening and at Adobe, and here we are. That I'll just post these links, and these are things that Sean shared with us in terms of just some larger questions in how to better approach complex multi-threaded systems. So in terms of better code, kind of like Arvin was saying, like we're all we've all been writing code for quite some time and have a good understanding of being able to write good code and better code. And it also helps with being able to maintain large scalable code bases to be able to kind of conform or at least understand good approaches to better code. And so I think a really great component of that is having someone like Sean who is engaged in the conversation of what that is. And I think that those links there are some of the things that he was talking about with us most recently, and hopefully they're useful to you guys too.
Yeah, and there's a question here about somebody who's just took a computer graphics class in college, and it's been way too long for me to like relate to be able to say like what to do next. But I think it's pretty clear. Um, it's not even about the portfolio or anything like that. Like my personal opinion is find a project that you want to work on. Be able to just start coding by yourself. In college, you can get so into like group work or smaller projects. It's really hard to understand like what a larger and being able to write an application or a game or a rendering engine or just a path tracer or whatever and just do it You'll learn a lot by doing that, kind of outside of classes. That's just my opinion. Like I said, it's been a long time since I've been to college, so um, I don't know if that's still kind of the case, but um, that's how I would start out.
That's fantastic advice. And I want to answer Vunk's question, or Wunk. I'm not. I hope I'm pronouncing that correctly. You got a really cool like avatar there in the circle. The question is um, about taking explicit advantage of certain CPU hardware functions. Yes, we use I believe Eigen, which makes use of a vast array of the AVX and SSE type of instructions, and it kind of chooses it based upon the kind of platform that's running. So it's really, really cool. And there's another question in terms of using RTX acceleration for other areas such as spatial audio. Our fantastic research team is looking into a myriad of different things, and it wouldn't surprise me if they're leveraging the capabilities of modern GPUs in such a way. Are we doing a good job, guys? Are we of answering questions? We're kind of running out of time, hoping to cover everyone. I'm not sure if we've missed anyone, so
I think we're out of time, so we might like start to wrap it up right now.
right
Else?
on. Oh, thanks for having me. I'm Phoenix. I will post my LinkedIn in the channel as well, and yeah, connect up and reach out to us.
Yeah, definitely, that'd be awesome. Thank you guys so much. We'll stay in the chat for a little bit, or like later today, we'll be able to see, especially if people are viewing this on recording, and you have any other questions, we'll try to get back.
Okay.
Thank you very much, guys. I left my LinkedIn. Feel free to reach out.
Yeah. So thank you guys so much for coming out and doing this. I realize you guys have a very busy schedule, but we seriously appreciate this. And yeah, I think this was a good first community event for you guys. You guys were actually kind of our guinea pigs, so thank you for that. I don't know if you
Well,
realize this.
definitely our pleasure.
Love it. Thanks for having us. It's fantastic to be reaching out to the community and doing this. We don't get to do it very often, so it's a lot of fun. Thank you.
Okay, yeah, just as one final reminder, they are hiring a senior software engineer. So if you are looking for a job, make sure to hit up FlashXC18 here on Discord. He is the POC for that job posting. All right, thank you guys.
Thank you.